Alrighty, today we're going over the Chapter 7 review. So for this first one, it's asking for each exterior angle of a nonagon. Well, all the exterior angles of everything is always going to be 360, the total. For here, a nonagon, that's 9 sides, so we're going to do 360 divided by 9, and that's going to give us an angle of approximately 40. Same thing for number 2. This one you're just going to divide by 13. If you get decimals, that's totally fine. Enter 2 decimal places. For number 3, they want the sum of the interior angles. Now, again, of a pentagon, which is 5. On your notes, you should have the sums already in there, but if you forgot, we're going to use the formula of n minus 2 times 180. Here, n is 5, so 5 minus 2 times 180 is going to give us a number of 540. You're going to do the same thing with 4, but n is 13 this time. For 5, a heptagon is 7 sides, but to find each interior angle, we first have to find the sum. So let's find the sum. So we're going to do n, which is 7, minus 2, times 180. So that'll be 5 times 180, which is 900. But we have to divide that by 7. There's 7 angles. So we have to divide our total, divided by our little parts, which are 7. And that is going to give us a whopping number of 128 let's do 57. Number 6, again, same thing. Find your total, divide this one by 20. 7 wants the sum of the exterior of an octagon. So exterior, remember, no matter how many sides, which an octagon is 8, no matter how many sides, will always be 360. The sum of the measure of the exterior angles of a 15gon, once again, exterior is always going to be 360. Number 9. I'm pretty sure we have seen this about 47 times, but let's do it once more. So here is a 4-sided figure. We know all 4-sided figures add to 180. So I'm just going to do that. So I've got 3x plus 6x plus 45 plus 90 equals 360. Okay, so that'll give me 9x plus 54 equals 360. And when you work all that out, you should get x of 25. 45 and 5y are a straight line, or form a straight line, which means the total angle there is 180. So 5y plus 45 equals 180. Solve that, and you should get 27. Number 10. Once again, this is a quadrilateral. We call math. Isn't that creative? So here, my quadrilateral once again has 4 sides, which means the sum should be 360. So I'm going to add up all my numbers. So you should get something like 7x plus 1 plus 7x minus 3 plus 11x plus 87 equals 360. And solve from there. 11 is a parallelogram. So looking at that, they are telling us the DAC, that angle is 63. They're telling us DEA, that angle is 89. And they are telling us ECD, right there, is 54. So I've gone ahead and just labeled all of my angles. Now we're going to see what angle it actually wants. It wants DAB, D to the A to the B. Okay, so knowing our parallelograms, we know that our opposite angles are equal. So we have parallel lines cut by a transversal, meaning that if this angle is 54, this one is also 54. See if I can make those go away there. So that is 63. This one is 54. When I add those together, I should get 117. Two. Once again, we're going to use that same parallelogram, and this time we're looking for AEB. This angle right here. Well, so far, we know that this one is 54. We know this angle is 89. So given that, these two form a straight line. So if this right here is 89, this one is going to be 180 minus 89, which will get us to the number of 91. Once again, same parallelogram. This time it wants CDA, this whole angle. Just scroll back up to see what we know here. Alrighty. So we know this angle is 63, and we know this angle was 89. So what we can do is we can go ahead and find, oh, actually, we also know this one was 54. Okay, so knowing that, here's our triangle. We know two angles in our triangle. It's going to be that angle and this angle. Three angles add up to 180, so we're going to do 180 minus 63 minus 54. And that will give us a number of 63. All right, next. 14. So we're going to use this parallelogram, same parallelogram, and they want DBA right there. All right, well, we know that this was 54. We found this angle to be 91. So we're going to do 180 minus 54 minus 91. And that will give you a number of approximately 35. We're going to determine if this is a parallelogram. So one thing that I would highly recommend that you use is that diagram or family tree that we had talked about on the back of your notes. So for a parallelogram to be a or quadrilateral to be a parallelogram, it's got to hit some of those requirements in that box. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, or your diagonals bisect. Well, here, my diagonals are bisecting. That is equal to that. That one is equal to that one. Because our diagonals bisect, that one is good. 16. So this appears to be a rectangle. It is telling us that QP and it's telling us PT. And they want us to find RT. Alrighty, so for this one, we're going to go ahead and set up our equation. So we are going to do 4x minus 4 equals 6x minus 23. Because this is a rectangle, our diagonals are equal, which means that is equal to that. So I'm going to get 2x equals 19. Let's see, is that right? Let's see, 2. So I'm getting x equals 9.5. Then to find RT, I'm going to plug it in. So 6 times 9.5 minus 23. And I'm going to multiply that by 2, which will give us a number of 68. So again, if you didn't follow that, I'm plugging this in for PT right there. So 6 times 9.5. And we're going to subtract 23. That'll give us just PT, which was 34. Then I need to double that to get RT. So that got us to 68. 17, QTR. So here is QTR right there. Is 3V minus 17. And we know RTS right there is 2V plus 11. Because we know that this is a rectangle, that means this whole angle is 90. So we're going to add those up and equal them to 90. So we're going to have 5V negative 17 minus 11 is going to give us, plus 11. It's going to give us minus 6 equals 90. So 96 divided by 5, 12.2. All right, so then they want us to find SRT. SRT right there. This angle is equal to this angle, so we're going to plug that in. 3 times, that should be a 19, 19.2 minus 17 gives us 40.6. Beautiful. 18, so we have QS, which is our whole diagonal, and we have RT, again our whole diagonal. We know our diagonals are equal in rectangles, so we're going to set them equal. 3x minus 44 equals 72. When you solve for this one, you are going to get x equals, no, I'm not going to tell you, it's a decimal. So I'm going to let you solve that one. 19. All right, so looking at 19, this is a rhombus. Okay, our rhombus has the following information. MHA is 31 degrees. And we know this side is 11. Now, as a refresher, rhombuses have everything from a parallelogram, and our sides are congruent, our diagonals are perpendicular, and our diagonals bisect our opposite angles. So, they want us to find HM. So think about the fact that all of our sides are congruent. Go ahead and fill that one in. 20. So again, same information. So this angle is 31 and this side is 11. They want us to find HTM right there. Okay, well, if we know this angle is 31, then this angle is also 31. And this forms a triangle. Another thing that you could do is that this forms a 90-degree angle. So you could do 180 minus 90 minus 31. Okay, and again, I'll let you solve that one and plug it in. 21. All right, so this goes to our kite, and they want us to solve for angle A. Well, where two mismatched sides meet, so A and H are equal. So an equation that we can set up to get this would be 360 minus 27 minus 74. And that will give us A and H, so we have to divide that by 2. Again, I'll let you solve that and plug that in. Here's our trapezoids. So remember, our trapezoids have that cool thing where it's the top plus the bottom divided by 2 equals that mid-segment. So for here, we're going to do 7 plus 14 and divide that by 2. Here we're going to have to set up an equation to get that x. So we're going to have to do this plus this divided by 2 equals 39. So I'm going to simplify that a little bit for you. 11x plus 1 divided by 2 equals 39. And if you're stuck here, as a hint to get started, you want to multiply both sides by 2. Again, I'll let you solve that one out. 23 is a whole number. 22 is a decimal. All right, moving on to 24. All right, 24. So they want to know which ones have both pairs of opposite sides parallel. Well, the opposite sides parallel comes from our parallelogram. So parallelogram, and under parallelogram, we have rhombus, we have a rectangle, and we have a square. If you remember, a trapezoid only has one pair. Isosceles, again, same thing. Under that trapezoid, only has one pair, and a kite has none. Which quadrilaterals have both pairs of opposite sides congruent? So again, that is one of our factors of a parallelogram. So under parallelogram, we have rectangles and rhombuses and squares. In addition to that, we have, trapezoids, no, and kites, no. So that's it. Kites have consecutive sides equal. All right, 26. So which quadrilaterals have one pair of opposite sides parallel? Only one, and that'll be all of our trapezoids. So regular trapezoid and an isosceles one. 27. Select all that have only one pair of opposite sides congruent. So only one pair of opposite sides congruent is just going to be that isosceles trapezoid. All sides congruent. Okay, well, our favorite friend, the square. And then in addition to that, the rhombus also has that. Where is that one? All right, moving on to 29. 29 is asking which ones have congruent diagonals. Well, our congruent diagonals come from, let's think here, the rectangle. And because the rectangle has one, the square also has one. And I believe that is also a property of our isosceles trapezoid. Let's see, we just did that one. 30. Select all quadrilaterals that have perpendicular diagonals. So that's when your diagonals meet. They form a 90-degree angle. Okay, that is going to be our square and our rhombus and our fun friend, the kite. 31. Which diagonals bisect each other? Well, our diagonals that bisect each other are again going to be all of our parallelogram family. So parallelogram, rectangle, rhombus, and square. And that's it. 32. Which ones have opposite angles congruent? All right, well, that is going to be our parallelogram family again. So parallelogram, rectangle, rhombus, and square. Kite does not, and isosceles trapezoid does not. 33. Select all the quadrilaterals that have one pair of opposite angles congruent. So opposite angles, only one is just going to be our kite. 34. So we're looking for quadrilaterals that have all of our congruent angles. So that would be our favorite friend, the square, and in addition to that one, our rectangle. Both of those have 90-degree angles. 35. Select all quadrilaterals whose consecutive angles are supplementary, meaning angles that are next to each other add to 180. So this one is going to be all of our parallelogram friends. So parallelogram, rectangle, rhombus, and a square. Kite is a no, and our isosceles trapezoid is also a no. Isosceles trapezoid, your opposite ones are going to be. Oh no, a trapezoid would. Quadrilateral whose consecutive angles are something. Yeah. So for that one, consecutive angles. Yep. So isosceles trapezoid and a regular trapezoid. Both of those have our consecutive angles supplementary. All right, 36 is just a picture. So that is it, guys. I hope you have a delightful day. Let me know if you've got any questions.